No. I found this 2 years ago. Well, I was really here at the time. I mean, not because of that. For other reasons.
No, I was told to go back to
Hey everybody. Good work. Way to fight down fast. Second grade class. All right. Thank you guys for coming to. You want me to be louder? I can turn this thing up. This is the red one. Is that louder?
It's the blue pill.
I already took the blue pill. Better? Is it not getting better?
It's the same.
Way louder.
Maybe
This is
it's
good.
you.
All right. All I see is people in the back going, look at that. Thanks again for coming to Functional Monthly 7. We love having these things, and thank you really a lot to RDO for hosting. There's a round of applause. First up, I want to have Justin from RDO say a few words about RDO.
Thanks. So I'm Justin Tullis. I work at RDO on the front-end team. For those of you who haven't heard of RDO, we have a music streaming company that, you log on, you play music, it's good stuff. So if you haven't heard of it, you should check it out. Our desktop product is all in the browser, so we write a lot of JavaScript. Some of it has functions. This is an area that we're deeply interested in. And we are definitely hiring if anybody's interested. There's a bunch of RDO front-end people around. They're not clearly marked, so you'll have to just introduce yourself to people. But we'd love to talk to you guys more. Thanks, sir.
All right, thanks, Justin from RDO. Next up, we have Steven from PubNub. And I need a couple of volunteers from the front row for him.
Oh yeah, thank you.
Is that not true?
No, that's totally true. Here, take this.
Okay.
Okay. Hello guys, my name is Stephen Blum. I am the CTO of PubNub, and I am changing the world. Oh cool, okay, can you hand these out to the folks?
Should I throw them?
Yeah, but carefully.
Anybody?
Alright, so I'm going to show you something pretty cool today. This is HTML5 JavaScript in a web browser. And what you're seeing here is live traffic running on PubNub right now. All the lines that you see are color-oriented for publish, subscribe. As it fans out, it's receiving data to devices everywhere on Earth at the locations that you see them. And what these guys are in the audience are doing is they've got full control over this browser using PubNub as well. So PubNub is controlling the display of PubNub using PubNub to show the status of PubNub. And come check us out. We're in the back, and we'd love to chat with you guys about all the cool real-time stuff.
Oh, and that's only 0.001% of the actual traffic, mind you.
Right, yes, definitely. Small percentage of traffic.
So the rest of it is dark traffic.
Yeah. Cool. Thank you guys very much. Thank you.
You want a phone back too?
Since this thing is cooler than the slide, we're going to leave this up while we do this next part. All right, tonight is the night of volunteers, and I need 5 people that want to participate in a JavaScript Survivor challenge
Uh-oh.
with gifts. Maybe you might win socks, you might win books. I haven't decided yet.
Animated GIFs, that's right.
GIFs. I apologize. GIFs. So don't all raise your hands at once. I do need 5 people. Dave's gonna pick out all the 5, so I'm not the bad guy.
3, 4, 5.
You all need to come up here and stand in a line. And I will be giving you a pen and a notepad to write your answers down.
Uh-oh. This is like Jeopardy, except harder.
Please pass these amongst yourselves. Do not keep these. These are property of RDO. Mr. Lonsdorf, I need you to maybe sit. Oh, yeah, that's fine right there. You're going to be the judge.
Thumbs up and thumbs down?
Yes. Okay, so we have all 5 people.
Use other fingers.
You can, yeah, that's fine. Over there. If you could tell me your names from left to right. You are?
Will?
Will.
Oh,
Walter.
Steven.
Stephen.
Would you?
Uju. Awesome. I was going from my left to right, but that's all. That's fine. All right. So the questions are up here, you guys. And I'll read them to you. And this is a test. This one doesn't count toward you being kicked off of the island. When aliasing this to another variable to keep it from changing, what is your preferred name? Please write your answers down.
okay, no cheating.
And I want you to hold your hand up when you're done, so I can see. Cool.
Thank you.
All right. So we're gonna go now from my left all the way to the right. What is your answer, sir?
My answer is bind.
Bind.
A.
Awesome.
I use shelf. It's the Scottish version.
Okay, best answer already.
All right. It is not answers by voting, just so you guys know.
I think I was the only one taking this seriously. I said $sign this if it's jQuery, that otherwise.
Okay. Okay. So we have that or self are the only 2 So how this game will work, not how it's working now, is 3 of you are gone, no matter how good your answer is. And we would have 2 survivors. Okay, the first real question of the evening. What is one common way to turn the arguments object into an array? What is one common way to turn the arguments object into an array?
They get harder.
Now, this is the easy one.
Google.
Google. Not an acceptable answer. But it would work. Remember, raise your hand when you're done so I can see. Time will come into play later in the game. You guys are welcome to play at home. You'll win nothing. Well, you might win socks. We'll see. Hey, Dave and Brian, tell me when everybody's done. I'm having a hard time seeing over here. Okay.
I think we're good.
All right. Same all the way to the end, all the way to the over here.
All right. I wrote left bracket, right bracket, dot apply, parentheses, arguments.
Very close.
Very close.
Sorry. Array. Dot apply, array, comma, arguments. Okay.
Okay.
Maybe it's not.
I think that works. That works.
Brian says yes. You've made it to the next round. Next.
I didn't know. I knew it was something with arguments, but I guess I just figured you could cast it and that would just be it.
I'm afraid you need to elaborate for that.
I'm sorry. Third person. I forgot what it is.
Dot to array method.
I think that also, does anybody know if that's an ECMAScript, anything?
Dot TOA.
Oh, 2 down.
I did bracket splice call arguments.
Oh, nice.
Yeah, there we go. You can read
array
books.
prototype slice arguments.
Nice.
Ladies and gentlemen, here are your acceptable answers.
Okay, that's the second one.
I'm gonna Google this.
Yes. You guys get socks.
Socks. I
You
could
get
Pair of
socks.
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 Pair of socks. And a book.
So please help yourself to a book.
Please take a book.
Well, obviously, I need to learn about JavaScript.
You're still in it, sir. You don't get a book for every round. You're still in it, though. Question number 2. What built-in function do I call if I want to know if an object is in the inheritance chain of another object?
Come on.
We know this one
It's
now,
almost
don't we?
spelled in there already.
Yes, I can. What built-in function do I call if I want to know if an object is in the inheritance chain of another object? No help from the audience, no
Oh, sorry. No.
phone a friend. You guys all? One more. You done? Cool. All right.
Household property?
No.
Oh, wait, what is it?
Don't use your location. For-
Okay, what are you doing?
Okay. No answer might be a no answer.
Is it instance of?
What?
Instance of?
Instance of?
Oh,
Yes, instance of is definitely an answer.
is it a good answer?
It's a good answer.
Instance of or x.prototype prototype of x.
Oh, that's X6.
No, this prototype of is old.
I feel like it was close enough.
Brian says close enough. Brian's had a beer or two, so we move on to question 3.
Apparently.
There's only
Okay.
7 questions, so we have to.
We have to keep everybody in as possible. Question 3. In a modern browser, how would you select all elements with a class name without using any external libraries? Query. In a modern browser, how would you select all elements with a class name without using any external libraries? See the heads cracking out there. Where are you going with that here?
In JavaScript?
Yeah.
Yeah.
No, you know what?
You can transpile.
Are we all written down? And pencils down. Sir, all the way to the left.
Document.getElements by class name.
Avoiding the modern browser.
Yeah.
Brian, is that acceptable? All right, Brian says yes.
Document.querySelector.
Yes, there it is.
On the board.
Yeah, that was my plan.
Okay.
Yeah, I had that too, yeah.
Alan gets socks.
Okay.
Used.
Question 4. Well, yeah, you're welcome. Is this right, Brian? What does it mean to shadow a variable?
It's a trick question.
What does it mean to shadow a variable? Please ignore the apostrophe S. I just copied and pasted this.
What does the Firefox say?
Wait, are all set? Okay.
To track its state as it changes and reflect its value.
Not really.
Oh, I'm sorry. Brian says no. You can have socks and a book. Thank you for playing. And then there were 2.
Oh, Angular.
So, if you neither of you get this, it goes on to the next one.
Yeah.
It could just be my shitty question.
It is. Go ahead. Poorly worded.
Yeah, poorly graded.
What's your answer? What's your answer?
What's your answer?
I didn't get answers.
No, I'm not. I'm just turning the answer off. Sit down. Go ahead.
Yeah, it means to replace override the reference in the closing scope, like a function scope.
Alright.
I don't know.
Okay. Well, you may grab socks and a book, and it looks like we have a winner, and we don't need all the other questions. Okay, well, so you, sir, as the winner, may take socks and a book, and you will be getting a full conference pass to FluentCon. Thank you for playing the Functional Monthly Survivor. Talk to Dave about your prize.
You can also go to the interview round now, too.
You guys want to see any other questions real quick?
Yes.
Brian worked really hard on these. How do I make a function private? Just yell it out.
Don't expose it.
Man, you guys are so smart.
But like it's just.
This is Brian's closure. Enjoy that.
The most ridiculous example possible.
AKA, you can't.
Underscore variable.
Define this JavaScript term hoisted.
That's like the scope is to the top, it's to the full function even if it's in a block.
Hoisting. Interpreter moving undeclared variables to the top of its scope. And the last one, name 3 JavaScript interpreters.
V8. Gecko, and what's the other? Rhino? Rhino one?
Rhino is one. Spider Monkey is correct.
Is it
There's
V8?
like,
V8? Is it
Brian
V8?
told me there's like 30 of them.
Is the V8 one also?
So it's like, if they stay on, it's
So Rhino, Spider Monkey, JavaScript core, Kraken.
Oh, correct.
You can say anything monkey.
Shock the monkey, man. Shock the monkey.
All right, I've taken up enough of your time. Next up, we have Brian Lonsdorf talking about whatever Brian's going to talk about. Functional patterns for the non-nup edition. Here's Brian. Echo. Echo. I'll be the man. Okay, I have to try to live code and hold this microphone. So this is going to be crazy. We'll see what happens. Don't look at this. I'm still using Keynote, and it's, oh, I have to plug in the H.
We'll give him some socks.
There it is, there it is.
Hey!
All right. Yeah, I don't know how this live coding part is going to go. I'm probably just going to be like, I think there's a way to balance this. There we go. Does this work? All right, maybe I can just shout. Can you guys hear me if I shout?
Yep.
All right, great. I can just shout. I got a microphone. All right, so this talk is kind of crazy. I was doing this for FluentConf. It's not ready, and I'm just doing it here now, and it's pretty bad, so we'll see what happens. But it's kind of an experiment. I'm gonna just like run through a bunch of stuff, like 1,000,000 miles an hour, and you probably won't remember or know any of it, but you're not supposed to. You're supposed to like see it really quick, and then we're gonna go try to use these things. Like, so you're supposed to kind of gather where and when to use it, and then we'll go try to use it in real code and see what happens. So we'll see. It's an experiment. It'll be fun. Okay, so you have this function that I wrote by myself that you probably don't know what it does because I wrote it. It's going to combine these two numbers, and I'm sure everybody knows what this does. And the reason you know what it does is because it comes from math, right? We know a lot more about it than what it does. It's got these properties. It even has properties like multiplication works with it in this certain way. It's associative and commutative and whatnot. So that's a pretty big advantage if you know what my function does before I even give you documentation. It's also polymorphic. It's got these, you know, a number's a number, a number's a number's a number in JavaScript. But you know, it can be because you can do fixed nums and big nums and ints. It's all polymorphic with add. It all works the same, so that's good. Anyway, by contrast, we have this function. This is my increaser that I wrote. And you can kind of gather, because I wrote it in plain English, and it's really readable. It's got this, you know, you make a new increaser, and we're going to increase by 2, and then you get the value out, and it's 6. But you don't really know anything else about it, and you have to go find my documentation to know like what other things it does. You don't really just see it and instantly know all these properties and things. And we don't know if it's polymorphic and whatnot. So this is the opposite of what we're kind of going for today in our pattern stuff. Nothing wrong with it, it's just not what we're after. So we're after these interfaces that are polymorphic and they're composable. That means it actually returns something that's useful for the rest of your computation. And then there's these properties and laws. I'm not really going to go too far into the properties and laws other than just show you them for 2 seconds and then move on to prove that they're there. So here we go. Wait, raise your hand if you know what kerning is. All right, I'm not going to go over it. If you don't know what it is, I'm so sorry. If you don't know what composition is, look at this really quick. All right, animation. Hello goes into reverse, it gets reversed, goes into capitalized, gets capitalized, and there's our answer. And that's how compose works. So you just give it some functions and it goes right to left. All right. But the cool thing about compose is that it's associative, just like add. So it doesn't matter how you group it on the inside. That means we can just write a bunch of functions like FGH, and you don't even have to write those inner composes. It also makes Martin Fowler's extract method really easy, because you can just pull out a subcomposition, because it's associative. They're all kind of grouped anyway. So that's really nice. We can just lift out any subcomposition we want. So you can write full apps like this, and it's great, and I've talked about that before. And so it might look like this. We're going to render a bunch of usernames in some template engine. But this is kind of a perfect world, right? If you've actually tried to write programs like this, you're going to end up hitting like asynchronous stuff and like, you know, error handling and whatnot. And that's what these patterns are going to address. All these like heavy mathematical things from the academic ivory tower jerks. So, all right, strap in. This is where we're going to get nuts and just go through like 10 or 12, you know, abstractions, and then we'll just go try to play with them. All right, so the first one, the pattern is getters and setters. Oh, and also stop me if you have a question at any point. All right, so getters and setters. There's a getter, there's a setter. We're actually mutating it here, but we're going to do it one better. So here's the pattern, and notice we return x, which is useful for composition. We're going to use lenses for that. Here's some functions, set, view, and over, and they all take a lens. Let's see how they work. Lenses export a ton more functions than this, but these are a good few. So if you look at how this works, we've got this user object, and we're going to make the lens name. And here we've got the function view that works with the lens name, and then set and over, and it does what you expect. You can view the name on the user, you can set it, or you can run a function over it. It's pretty great, and it always returns that user back, except for if you're actually viewing it. So it's pretty composable. In fact, lenses actually compose with themselves. So here on this first name, char, we're actually going to compose the name with the first, so it'll grab the name of the first, and then it's going to use this built-in index lens to grab the first character of the first name. And we're just going to uppercase that. And we get the full user back. It just kind of peers in and gives you that little part of the data structure and lets you run functions or view it or whatever. So that's lenses. They've got these laws. You know, you make concrete examples. They're dumb, super easy to look at. But there's stuff like if you set it twice, it's the last set. Okay, that's lenses in 10 seconds.
Wait, I don't think you said what lenses give you over the original get set.
Well, they're composable. Oh, they also are immutable. And they're polymorphic, and they're built upon functors, so you can use them in context. We'll see a little bit more of them as we go. But thank you, because I didn't mention they were immutable, did I? All right, we've got another pattern here, null checks. So is this cutting out, or is it just me?
It's cutting out.
It's cutting out? Is it like when I do the robot? All right. I mean, yeah, I'm fine. I don't need to stop. We're supposed to be going fast, you guys. So we've got this null pattern here, and if it's there, we want to run the function. Otherwise, don't do anything, right? The way to do it in a functional setting, or a Haskell setting, I would say rather, or category theory, is you've got this maybe object. We're going to drop our value inside it, and then fmap our function over it. Let's see how that works. So maybe is a constructor function that takes our string hi. If we fmap a function over that, where x becomes the string hi, and we'll call to uppercase on it,
and we get a maybe I capitalized. So that fmap actually asks maybe to run this function, and x becomes the property inside maybe. And if the property's not there at all, if it's just null, it won't run it at all. Maybe it'll be like, no, I'm not gonna run it. But it still comes back with a maybe, which is important. It's not just a null, you can keep changing these things. So that's how maybe works. And you can actually just drop it in compose here, because maybe is just a function, even though it's a constructor function, and you can partially apply fmap like that. So you'll see this more later. We've got some laws, there's identity, here's composition, or no, wait, I went backwards. Here's composition, which means the right side is a lot faster. If you've got an fmap and an fmap and a compose, you can just do it once. Okay, another pattern. You guys got maybe, right? Done. So, maybe I'm confusing. I'm just gonna yell, right?
Yeah.
Let's just yell. All right. I feel powerful with the microphone, but that's okay. It's just my problem. So let's do error handling. If we get an error here, if we have a null, we want to actually say something. We don't just run the function and just ignore it if it's not there. And the way to do that in the functional setting is about the same thing, except we're going to use this either. Can everybody hear me in the back? Yeah. So we're going to use this either function or constructor. And let's look at how that works. So either is going to take these two values and return a subclass based on the values it gets. So if this right value is there, it's going to return the right subclass. And if it's not there, it's going to return the left subclass. So left and right, it'll return a right or a left. But we put the error message in the left. Let's see why we do that. Well, if you run the fmap on a right, x becomes that 2, and we're going to add 1 to it, and we get a right 3. Just kind of like makes x whatever is inside the right, and returns a new right. And left is just going to be like, nah, just like a maybe, it says, I'm not going to run this function. I'm just going to return. But it still has the error message in it. So that's how fmap works when you give it a maybe. And you can return right or left on your own, or we can use this either constructor function to kind of capture that if it's not null or throw an error kind of thing. So here we'll just partially apply either with our error, and then we're going to partially apply fmap, and it composes just like that. And the fmap laws were the same laws as we saw before, because it's just fmap. So awesome. Another pattern! Sorry, we're going to get crazy. So callbacks. We've got this futuristic value that's not actually there. And when we run this function where we get callback, well, the way to do that is with a promise. So we can just drop our value in a promise. It's not actually there yet. This is just the concept. It actually kind of looks like this. So we're going to make our new promise, and then we're going to fmap this function over it. And x will be the value when it's ready, but it returns a promise, so we can keep on chaining. And then when we resolve the value, it goes ahead and reverses it and logs that, just like everything else. You have this intuition about how it works. Plus, it has to adhere to those fmap laws we saw before. So it's always going to return a promise. And this might be a little bit incorrect. There's been a lot of debate about it, but that's fine. It works fine for me. Okay. It's JavaScript, right? Who cares? So we've seen fmap a billion times. The whole thing is it's a functor. That's what anything that works with fmap or anything that has a map method, because all my fmap is doing is calling .map on whatever object it gets, which basically means run this function on your property and return the object back. All right, another pattern. This is where it's getting a little bit more crazy, and I just went through a lot of crazy stuff. So is everybody okay? Does anybody want to throw up? There's like open windows somewhere, I'm sure.
Socks.
Oh yeah, it's a pattern. It's matching. Pattern matching. All right, so we've got this nested stuff. And this is just our maybe, right? But it's going to nest more and more and more. As we run our functions, it's going to return another value. And if that value is not there, we want to do another thing with that value, and so on, etc. Or this callback nesting stuff, aka a node app. So you got this nesting situation, and the way to solve that is with this thing called mjoin. It's our monadic join. Let's look at how that works. Because we're going to fmap along, but we have to nest, and we'll see why it nests and how to fix it with this mjoin. So how does it work? Here's a big example, so let's talk about it. Hey, it's that answer. Anyway, so we have this Greek function, right? And it's going to take this query selector thing and then get the field, but it's going to put it inside a maybe because it might not actually be there. So we're going to fmap get the value over that, and that'll grab the value of the field and put it in another maybe. So it's this nested maybe inside a maybe. And then we'll have to fmap concat hello to it. And we end up with a maybe hello Chris or whoever entered whatever name. But the idea is you've got multiple maybes and they're actually getting nested inside each other. And the way to solve that, this situation you don't really have to think about. You kind of just fall into it if you're doing functor stuff. You're like, oh crap, I got a maybe and a maybe. So all you do is just drop this mjoin in there. Done. It just joins the two maybes together. And you drop it in at the point that is going to get nested. So we have this get field right here. We've got this get field. And that returns a maybe. And then we fmap over that with get value. At that point we have a maybe, and we're going to mjoin it to just get one maybe again. And everybody's happy, all is right in the world. So this is kind of tricky. We'll see it in the real code in a second. But oftentimes you're going to fmap, then mjoin, then fmap, then mjoin. It's going to be this pattern of I want to run this function and this function. And to make the laws look really pretty, we're just going to define mcompose as fmap mjoin, and proof there are laws. All right, so another pattern. We're like 2 more left, all right? Stay with me. All right, so here we have, there's 3 more, it's fine. So we've got these 2 different functions, or 2 different values that might be null. They're not necessarily nested, but 2 separate values that could be null. And we want to run our function with both of them. So we've got a function with multiple arguments and 2 things that may be null. Same thing with the parallel stuff. There's multiple parallel things going on, and you want both of them to be done before we call our function on it. And that's a pain in the ass if anybody's ever tried to do that, right? So let's look at, and you can do the same with either and whatever else, functor. So the way to solve that is lift A2. So we've got our function that takes 2 arguments, that's why it's lift A2. And then we've got our, you can replace A with like maybe or promise or whatever. We've got these 2 values in a context, these 2 functors. And if the function takes 3 arguments, we've got lift A3, and you can do that. So if these were promises, it would wait for all 3 to be finished before it called F. Or if they're maybe, they all have to be there before it runs. And we'll see how that works. But you get lift A4, lift A5. If you're doing lift A6 or 7, I'll come down there and slap you because you can have that many arguments in a function. This is how it works. Add is just going to take 2 maybes and add them together. So it just kind of like adds the 2 inner parts, right? It's fine.
Can you write that something takes like array of maybes?
Well, you can. It's not really variadic with this part of it, but there are ways to do that. We can talk about it later. But this part is if there's a null, it just doesn't run at all. So it's JavaScript, so we can bend the rules a little bit, but I found that doing that was a little weird. Ended up causing more problems than it was worth. All right, so let's see. So that's how it works with maybe, right? If one of them is null, it just doesn't run it. Same thing. But you can think of it as an fmap for a function that takes more than 1 argument. You're like, oh man, I wanted to do fmap, but I have more than 1 argument. I use this. And here is another example with the promises. We've kind of seen this, kind of like half-baked, so I don't want to go over it. But basically, it'll get called when both are done. And it's got laws. Okay, another pattern. Like 2 more. Does anybody have questions yet?
Well, this isn't,
What's that?
this isn't really a pattern, this last one here.
This is my pattern that I wrote. So it hurts me deeply. So I'll switch that before the fluent comp where this matters. I'm just kidding. Alright. So we've got accumulation here. Here we're going to reduce this function. It starts with 0, it's got plus. Here's another one, we're going to reduce this function that starts with a 1, it's got times, you get the product of it, this is the sum, right? Here we've got 4, it's going to return true if any of them are true. Here we've got and, it's going to return true if all of them are true, otherwise it'll be false. It seems to be a pattern, right? We're seeing the same thing over and over again. Here's one that's a little bit different, but it's basically A is it greater than, or keep it, otherwise don't. And this one will grab the highest value. What we're looking at is monoids. And in particular, we're looking at this mconcat function. Forget the other ones, so you don't need them. All right, so what we're going to do is capture that reduce in the type itself. So we can mconcat the sum of all these numbers, or we can mconcat the product of all these numbers, and it's just going to take as many stuff, just like you were hoping a minute ago, but for a different thing. Anyway, it'll take a list of all of them and just like fold them down. And we've got max, and we've got any, and we've got all, and it works for all sorts of things. So those things we were looking for, we've kind of hit them. You know, the polymorphic, and it's got laws. Let's see if it's got laws. It's got laws. And it's imposable. And that's the pattern with all these things. They're very generic. They work for a lot of different things. These academic idiots are coming up with some pretty cool stuff for us to use if we just look. All right. This is the last one. Yeah? Thought for the last one? All right. If you want to run two different functions on X, which actually happens quite a bit, and you're like, how do I do this? These little combinators, you can just write a function and do it this way. That's fine. But there's some other cool things. You might want to do this too. You might want to run X and Y. You want to run F on X and G on Y, and like kind of combine functions in different ways with different arguments. We've got these arrows here that they actually expose their own compose. And we've got these other helper functions. We're going to really focus on ampersand and asterisk here. But it's pretty interesting how it works. So this will run it on the first one, and this one will run it on the second one. And ampersand, which is pretty cool, will run both functions on X and return that array of the results. Same asterisk will run each function on each argument. It's kind of like a zip list, for those of you who are familiar, and return the results. This is pretty interesting because you can build up computations that take multiple arguments and run kind of two different paths. So it's got laws, and that's it. So let's play with some code. That's my Twitter handle if anybody wants to yell at me about that. All right. How am I doing on time? We're just gonna like go. Let's just go for this. Yeah, I wanted to go as fast as humanly possible. Here we are. So, this isn't what I wanted. Hold on, guys. There it is. Those are the answers, not the answers. All right. Okay, ignore this stuff. Let's make the font bigger, huh? So, I'm going to prove to you that you kind of maybe caught something in that blast of information. And maybe not. Maybe you'll prove to me that this is the worst idea. But how do I? Is there like a hotkey?
Option plus.
Oh, there it goes. Yes. All right. Extreme zoom cam. Wait, move. Anyone? All right. So here's our little program. We've got this comment, and we're going to show on the screen, but with just a log. But you can imagine like inner HTML or an API call or whatever. What we're going to do is just pluck the body from it, mark it down, and show it on the screen. And it's our hot new program, and everybody loves it. And there it is. I don't think you can see this either, huh? There we go. Whoops. There we go. Yes. See that? There's the output. So this is a great post. I wonder if I can not use total terminal. Just use terminal for this since it's so low. I can. It took over my machine. All right. Well, there it is. Awesome. Cool. So that's what it does. But then our fictional boss comes in and says, I have a new requirement, and you got to show the whole comment on the screen. And while you're at it, I want you to turn view to true. So still mark down the body, but I want show on screen to show the whole comment. And well, the thing is, once we pluck the body, the rest of the comment is just gone. It's done. It's over. So how are we going to do this? Now, we could write our own function that mutates it. But does anybody have an idea of what we should do here? It's the first thing I talked about. It's lenses. So what we could do here to keep the comment intact is say, we're going to make some lenses. We'll make one for the body, because we're going to alter that. And we're going to make one for viewed. And then what we'll use is saying, all right, we'll say over the body, just mark it down, and then we're gonna set the viewed to true, and that's all there is to it. So if I run it, I get the full comment back. It has the altered body. It made a copy for me. It set true, viewed to true, and we satisfied our stuff and kept our job. Hooray! So all this code is available. I posted the slides, so you can go mess with it. But the thing is, that'll come up if you're trying to write these programs and you don't want to write your own functions. You want these functions to be done for you. So, all right, another thing that we're going to look at here is this little program that says it's going to get some words and it's going to do this really awesome word count. It's going to tell us how many words are in here. And if I run it, it tells me there are 4 words in that I gave to my program. And if I don't have any words, let's say we're getting some support calls and someone's like, hey man, I'm running a program and it just like blows up in my face. And it says, I can't read property length of null. Well, what's happening is there is no match for these random symbols. So null shows up right here. We get a big fat null, and we try to pluck the length of null. So does anybody have any idea what we would use here?
Maybe.
Yeah! So we're going to drop a maybe in there. And since we put the maybe there, now we have to fmap pluck over it. So that'll do it. Oh wait, let me move this to the top again. So we get maybe null. Hooray! It didn't blow up. It told us maybe null. And if we write some words, we'll get maybe 2. Fantastic. So it didn't blow up anymore, and it just returned null. So what's interesting about this, though, is let's go ahead and actually refactor a little bit. Let's make this get words. And now we know that every time I try to get words, I may not actually get words. So we've kind of marked the beast. We've said, oh my gosh, this might not actually return something. And you can see that plain as day. And now we'll just have to fmap over it to get the length. So that's pretty neat. And if we want to continue adding things to this, like let's say we want to concat, the length is, it's not going to be, after you fmap, it's going to be a maybe right here. So you're not going to concat a string with a maybe, so we have to fmap that again, right? And that's kind of a pain in the butt once you start working with these things. I haven't purchased my supplies. That's because I use Vim all the time. So, this length is 2 inside the maybe. Hooray! We like jumped into the maybe with the fmap and concated that. And if we mess up with the words or do whatever, it's still just going to do maybe null. Well, if we look at those laws from before, we can actually tell a few things from those laws. We can say, oh yeah, well, I'm working with functors, and I know if there's an fmap and an fmap inside a compose, well, that's just, compose, fmap compose, right? So we can just do it like this, which is nice. And hey, I know any subcompose can be kind of lifted out, right? So I'll just pull that out into its own function because of associativity. So let's do show length, and we've got this function, making syntax errors all over the place. But now we can just fmap show the length, and we were able to refactor without, it's just, we don't even have to think. We can be like, oh, I see 2 fmaps in a row, we can just pull that out, and I know compose lets me do that too. If we run it just to be sure, we'll still get maybe null, and a hello, just make some work. Alright, works. Okay, so let's try a few more examples, but are you guys kind of seeing like what the whole idea behind this is? We've got these properties, and we've got these generic functions, we've got these abstractions and these polymorphic fmaps and whatnot. We're able to just compose it, and it's doing a null check right there for us, right? What's up?
It seems great. Are you going to talk about when it breaks down at all?
Where does it break down? Oh. Well, this is, let's just keep going and we'll see some crazy shit. But this is where, like before, I wouldn't have known how to do a null check other than going to do a function saying, well, if it's there, run it. And then it's going to return a null, and then I have to do that again, and it's going to be a big pain in the butt. So this kind of does that for me. But let's say our fictional boss comes back with a new crazy requirement, like all those patterns books that you're going to read. And it says, to keep your job, you need to tell those users that, you know, they need to give us words. You can't just not do anything and tell them maybe no. What the hell is that? We're going to say, you know, we have to do some kind of error handling in here. Does anybody know what abstraction we might use for error handling?
Either.
Yeah! Are you guys like, you just know this already, don't you?
Well. No, it was very clear.
Exactly. I just went into your mind and just implanted stuff from before.
Burns.
So we have either, and we can put our error message here. We can say, you need to enter words, man. Bro. So, and now if we run it with this, we can get our right back with the length as 1, or if we don't actually enter any words in, we'll get our left that says, hey, you need to enter words, bro. So that's fantastic. Can you guys all see that, or is that too low in the back? I could clear it and do it again. So awesome. That's how that works. All right, let's up the ante a little bit. Let's say we want to do some asynchronous stuff, and we're actually going to read a file and take that file's context and count the words from that. This is our biggest programming challenge of our life here. So, we're going to get this free function called readFile. That's you know, it's just going to take a string and do the promise work for us and give us a promise of the string. Awesome. Okay, so that's the signature. It takes the strings, gives us a promise of the string. Now, if let's do a little bit of refactoring here, so I can kind of get that in there. So program is now going to become compose our read file, and then let's rename this to like show word length. All right. So there's our show word length. Whoops. There we go. And there's, this isn't going to work because read file is asynchronous. So we have to do this thing that we've learned to do with everything at this point. We have to write fmap around it. There we go. And I have this word from this like whole lithograph thing I was going to do that I didn't do. So name Gatsby.txt. And if I run this, what's going to happen is I get a promise back. Well, that's not very useful because that's what we're logging, right? But, was that? If we fmap log over it, we'll get our whole program. Hooray! The length is 82. There are 82 words in that file, whatever that file is. We've done the same thing for everything. We've just put fmaps, and we've used our intuition to kind of grab whatever's inside this context. So what do you guys want to do next? We can do like a couple more. We could be done. We could talk. We could hang out. I don't know. What's up?
Yeah, that's a silly question, but all these functions, what is this, like in a library or something?
Yes. There's this thing called a fantasy land. And a lot of real world programmers like to tell us to live in the fantasy land. And so there's a spec that kind of says how all this should work. So there, if you check out Fantasyland.js, there's all these either, maybe, yeah, so promise, and that'll all be there. But it's all very Scala-ish. And so I just wrote this point-free fantasy that just takes that stuff and wraps it. So it just delegates, so you can kind of compose it this way instead of doing the dot syntax. But it's now you have a preference, right? Probably Scala is probably the right thing to do. This is just really fun.
No.
So, all right. So we could look at monads here in a second, or we could look at arrows, or we could look at monoids. What do you guys want to look at? You want to do like, let's do one more. Let's do one more. We probably want to look at monads, right? That's like everybody's favorite. Okay, let's look at monads. So let's get to the monad example. All right, here we go. Monads are super easy. We already saw it. It was just that mjoin, right? So here's our maybe program, and what we're going to do, we're going to alter it to take an object that has text on it. And that's it. We're just going to like take that text and put it in a little object that has text. So to get the text out, we'll just pluck the text. And then from there, it's you know, going to go through its thing. But what if it doesn't have text? What if this text is null, right? Well, what we have to do is say, oh, I put a maybe here, right? And then it's going to have to fmap get words because we put that maybe text in a null. Or yeah, maybe text could be null. Let's go ahead and pull that out in its own little function, get text. So we're going to get our text, and then we're going to fmap get words over it. But now we've got a maybe and a maybe. See, get text takes some string and turns a maybe of it, and then get words takes some string and turns a maybe of it. Right here we're going to have a maybe inside of maybe. Like right about here, it's going to be a maybe, maybe, and whatever get words returns, like, you know, some word it matches. Do you guys, is that clear? Is that making sense? Okay. So from there we have to fmap show length, and we'll do that, and we'll look at what that is. What number am I on? 3. And there it is, our maybe, the length is 2. So we just throw our little magic join in here, and there it is. It's monad join or magic join, I don't care. And then it just joins it, and we're good. So that's pretty nice. What it's actually doing is, what's up?
What if the property text isn't in the object you're passing?
Oh, like
If it was misspelled as in test instead
test?
of text?
Okay. Let's go ahead and throw. Oh, okay. So this goes through, and it's gonna pluck the text, but it doesn't get it. So if I do like test.
Exactly, yeah.
Well, that's great because it's gonna try to pluck text, and it's not gonna get it because it's test, and it's gonna put it inside a maybe. So we run that. We just get our maybe null. It says, no, I'm not gonna do it. What's up?
Suppose you wanted to report at what point it went bad.
Oh, okay. We could actually write our either. Oh, that's a good question. Let's see how this works. So no text, and we'll change this one to a no words,
That's a little manual.
bro. And we'll check that out. No, I don't have either. It's not defined. Let me grab either from one of these other giant messes it requires. All right, so. And I don't have a monadic instance of either yet. Hold on, I gotta define chain for either, but it'll work like that, I promise. I just have but what's gonna happen though, what's interesting is if it doesn't get words, either it's gonna return to left, and it's gonna return that. It's just gonna ignore everything else and just propagate almost. And if it gets that, it'll just, you know, be the either and the either. So the spec is it's going to be chain, and so this M join here, you actually often see it as M bind, or flat map. So if we look at flat map, all it is just fmap M join, done, right? So if we go down here and we just call flat map, now we don't have to write the fmap and M join, and that's our M bind, chain, you know, flat map, all those things. In fact, if I want to say, hey, if this is not there at all, if I just get a null here, we have to put it in the maybe in the first place. And then we have to flat map this guy, because we're going to have a maybe and a maybe at the end of that. And it ends up being pretty straightforward to say, like, well, map then flatten. That's what flat map has, right? It's just going to return an extra thing and you join it afterwards. But it's pretty cool to see this sequential thing handling asynchronous stuff and null checks and errors and whatnot. So there's that. We could look at monoids and arrows, but I think it's better to just hang out on top. What do you guys say?
Let's take a few questions.
Oh yeah, let's take some questions. Why not? What's up?
So can you reduce this to just one long line?
Yeah, if you, there's this thing called Uglify. But you probably can. You just get rid of all these intermediate variables. There's the SKI combinators, turn complete. We can just fucking go crazy. Why not? Those are actually defined, I think, in this SKI. So, any other questions? This is pretty experimental. I want some feedback because I don't know if this is gonna work. What's up?
Quick question. You explained monads and functor. Like you didn't explain applicative.
Oh, applicative?
Yeah.
Oh yeah. Well, yeah. I can give a quick applicative example. So, yeah, here. This is a better one. Okay. So we've got this make user function that's going to call makes a user, and it's going to make Saul Woodsman. And if I run that, let's see what number we're on, run 4. So Saul Woodsman was created, right? Now applicative is if we look at how this is going to go down, we want to do some validations. What if null comes through here and we don't actually have a last name? It's going to say, oh, Saul null is created. That's not cool. Stupid JavaScript. So what we could do is say, let's make a function called create. That's going to do some validations, right? And it's going to take its first and last name. And what we want to do here is actually use our applicative to call make user. And we want to tell it either you need a first name, first, or either you need a last name. And it takes its last. So this is going to return either lefts or rights, right? If it gets a left, it's not going to run this. But if it gets a right, it'll run it. So the caveat is that, I love that word, is that make user is not going to be, it needs to be curried or else this will not work. So we use our favorite Lodash curry function here, and now let's call create instead of that. So we're going to get our right Saul Woodman was created. If we get a null here for the last name, we'll get a left, hey, you need a last name. Or we can do the same thing with the first name. And at that point, you need a first name. You've got these fancy validations. There's a better way to do this. You can actually use a monoid instance to concat the validations inside with like a. But either way, it's pretty neat. It's just basically like, I wish I could fmap make user over this, but I can't. So it's because it's got 2 arguments. So I'm just going to lift A2. That's pretty much the situation I use it in. Or here we've got like 2 different API or read files that are asynchronous, and we could just use both of them. Cool. And there's answers and GitHub stuff on the meetup.com site, so you can go destroy it and then yell at me. There's no chain instance for either. Any last questions? All right, sweet. Thank you guys so much.
All right, so we always do one thing before the end of the meetup.
Can you guys? Shit, there we go. We always do one thing before the end of the meetup, except for last meetup when I forgot and I got yelled at by like 3 different people. So I apologize that I forgot. But if you got an interesting idea, something that you've worked on that's cool, and you want to get the chance to tell everybody about it, but you don't want to buy awesome Thai food like Ardio did, feel free to come up and you can make an announcement right now. By the way, the Thai food is actually from Krua Thai on 16th and Guerrero, I think, right over there. And I'm so happy that we got Thai food instead of pizza, so thank you, Artie. So anybody want to come up? I mean, I don't know if this is true. I saw this as an example of like a bad idea. These pencils that were withdrawn from U.S. schools.
That's funny.
It says, too cool to do drugs, and as you sharpen it, it says cool to do drugs, drugs. If you have a better idea than this, then feel free to come up and you can announce it to everybody. Anybody? No?
I'll just at least.
You were just up here.
I know. I got one more pattern to show you.
Okay, do it.
It's the pencil pattern.
I just want to say I ported most of Komet's lens library, but I need help on traversable and foldable stuff. So if you want to help me port Komet's crazy lens shit, hit me up, Dr. Boolean at Twitter.
Dr. Boolean on Twitter.
Yeah.
Okay, awesome. And also, I just wanted to say thank you to our sponsor, PubNub. They're the reason that we're able to get, for example, live streaming for this meetup tonight. So thank you guys back there.
So we actually, we killed the keg back there, but you guys feel free to hang out. There's like a patio out there. There's a fire. I don't know if it's still on. There's like warming devices. I don't know. It's pretty crazy. Feel free to hang out. Thank you everybody for coming. Thank you to our speaker. Thank you to our sponsors. Good night. Video? Yeah. There's a link to the live stream on meetup.com, and I'll crop it down. Like, you'll have to fast forward a little bit. But yeah. Dude, thank you for participating. That was awesome. That was awesome.